Hello. On this webinar, we'll touch on three of the most common cloud vulnerabilities and how Infinicrate can help your team conceptualize and defend against these threats. To start, cloud adoption is widespread, and with so many providers to choose from, it's no surprise developers need to consider security more now than ever to implement secure operations. Like with any system, aspects of security or software misconfigurations that seem inconsequential can snowball into larger security incidents when multiple flaws are combined by a determined and skilled adversary. The adoption of so many new cloud offerings in a relatively short amount of time has meant developers are constantly required to keep on top of the latest emerging threats. While attention is often paid to the most recently adopted and cutting-edge components, parts of multi-stage exploits often start with or involve violations of core security tenets, or simple mistakes introduced into code or configuration. What this means is building applications in the cloud comes with a unique set of risks. Not only do developers need to consider the security requirements that come with each cloud provider, but creating cloud-native applications often involves the use of containers and infrastructure as code. These technologies can be a boon to reliability, scalability, and even security if proper measures are taken to secure each component. Let's start by covering three of the most common vulnerabilities we're seeing in cloud environments. To start, insecure cloud, container, or orchestration configuration. As applications and their backends get larger and more complex with time, orchestrating secure deployment gets more complicated and, importantly, more crucial. Infrastructure as code allows us to implement an automated process to deploy components' reliability and scale as user load increases. However, misconfiguration introduced to this process can also cause repeated issues. Special attention must be paid to cloud provider and tool-specific configuration best practices. The second vulnerability we'll be covering is insecure secret storage. Secrets are core to almost any securely developed system. Whether it's access tokens, user credentials, or API keys, ensuring secrets stay secret is key to keeping attackers at bay. While cloud providers have introduced services to securely manage secrets, we still discover hard-coded credentials and publicly accessible secrets to this day. It's important to understand which secrets the system will manage and the ways those assets will be protected. And finally, CICD pipeline and software supply chain flaws. Adopting a CICD, or continuous integration and continuous deployment or delivery, processes internally can allow security to be baked in at every stage of the development process. Unfortunately, implementing this methodology without considering the security implications can allow attackers to view code repositories, extract secrets, and even force their own malicious code through the pipeline. Not only is it important that the right CI/CD tools are selected, but their configuration can be just as important as the more visible application layer security. Now, these concepts can be hard to visualize without getting hands-on. Introducing Infinicrate. Our latest cloud range replicates the cloud infrastructure of a file storage company using AWS to host their cloud-native application. Players start off by getting access to a bug bounty program run by an advanced hacking group. This provides the narrative framework and rewards players each time they successfully complete a mission. The file storage application, blog, and admin console replicate the business logic and user activity of a real-world application. Players get to see how the mistakes of Infinicrate developers provide the toehold that will allow them to reach the lowest levels of the organization. Once inside, players will use the AWS CLI and web console to explore the Infinicrate environment, view and take advantage of misconfigurations in AWS services, and extract secrets from the code repository and key management service. Infinicrate is a challenge even for long-time AWS developers, and experience with AWS is a must. As with all command and control ranges, the best way we found to teach and reinforce the concepts is through hands-on learning. Learners will take the theoretical and see exactly how an attacker approaches investigating and exploiting a vulnerable cloud application. Because the application and AWS accounts are instanced for each learner, they can exploit vulnerabilities in a safe sandbox, resulting in a legal hacking experience not available anywhere else. Team play is available through the platform, allowing different roles within a company to work together, share tips and tricks, and learn that every team member who touches the development lifecycle needs to play an active role in keeping their organization secure. With that, let's dive in and demonstrate 3 of the vulnerabilities in Infinicrate that show these challenges. Let's first take a look at the Infinicrate application before we start looking for vulnerabilities and misconfigurations. We've created a file storage solution where users can upload files, store them securely, and even share the information with others. What you don't see, and learners will discover, is that the application uses cloud-native services in a fully sandboxed AWS account we've provisioned. If you get hands-on with Infinicrate, I recommend you start by canvassing each site for the secrets and hints lurking just below the surface of each page. I've already created an account, so we'll log in, and we're presented with the main application interface. Just like all command and control ranges, this is fully functional, and we can go through and do some initial exploratory testing. This being a file storage solution, let's start by taking a look at one of the most potentially juicy targets of the site, the ability to access other people's files. Being able to view private information on an application that touts its security would be pretty devastating for customer trust. Thankfully, Infinicrate has made exposing your files to other users very convenient through this public files browser. We can see what other people have uploaded, and it would be worth going through some of this material in depth. What I'm interested in now is how this information is being shared. If it's using a cloud storage provider, there's a chance the way the storage is provisioned will allow us to view more information on what files reside there. One of the most basic places to start is by walking through the URL of a file to see what you can find. Depending on how things are configured, we may see something interesting. This bucket has publicly accessible metadata on what files are being stored within it. You can see not only the information on where the file is located in the bucket, but also whether the file is public or private. I, of course, want to see whatever private files we can view and attempt to download it, and are able to. This allows us to start delving a level deeper and start seeing which files are being hosted on the application. Exposing metadata seems like a simple oversight, but vulnerabilities like these have exposed many credentials and secrets over the years. Again, these small mistakes often are what allow attackers to gain a privileged login or shell access that they can use to further elevate their access. What I haven't told you yet, and another thing learners discover immediately when they start playing, is they've been recruited by an elite group of hackers through the crowd control bug bounty platform. Currently, they're offering rewards for the discovery and exploit of vulnerabilities in the Infinicrate environment. We can see that the file I found is the answer to one of these posted missions, and by submitting it, we get rewarded with points in command and control. This opens up many more avenues for us to pursue, but for now, let's continue to run through the application. The next cloud threat is insecure secret storage. This can take many forms, from user credentials stored unhashed within a database, secrets stored in a publicly accessible file or Git repo, or routine logging writing access keys to logs. In the file we downloaded were credentials that got me access to the AWS environment. This small oversight led us right into the internal network, which from here, learners will start to explore and see what's available. One of the first things we'll do is check out the internal Git repository and start shifting through the code we've found. Git is an industry standard for storing and maintaining access to code, and one of the tools that Git uses is a log functionality that lets us see what people have changed in the repository over time. Looking through the history, one comment that catches my eye is removed S3 credentials. It sounds like a developer caught that they had embedded credentials in some part of the code. Assuming this was the case, they were smart to remove them. But what we can do is peer back through the history using Git's tools and see what they removed. Looks like this could be it. Here's another tidbit we want learners to walk away with. Secrets stored in internal tools, even those in places like repo history, can come back to bite if those same tools are accessed by an external or internal attacker. Now, we've already been looking at a crucial component of almost any CICD pipeline, a code repository, but so far we've only viewed the data that it contains. Depending on how it's configured, we may be able to push our own code through the repository, a key component of many supply chain attacks. We have access to code which is used to define their Lambda functions, a very powerful tool used to run code without requiring an expensive server. I'm going to modify this, and at first, not necessarily do something malicious, but just a proof of concept to see if it's possible. Another threat is attackers obtaining a foothold into a corporate environment just to sit and monitor activity for months or even years before changing code. Since this is the case, I'll try and avoid detection. I'm going to commit it to the repository. No authentication needed. From here, we can work to craft an even more sinister attack, one that modifies the internal functionality of the application itself to siphon off data or leave a backdoor for later access. Working with my hacker contacts through crowd control, they're able to detect my changes and award me points for making that change. That about does it for the 3 cloud threats I wanted to demonstrate in today's video, and we've only scratched the surface of what's available within Infinicrate. This demonstrates how through some light reconnaissance and reverse engineering, we can see how components were deployed with security oversights in place that gave us the tools we needed to pivot even further into the application and organization itself. Thanks for watching. If you get a chance to experiment with Infinicrate yourself, make sure you or your team are ready to exercise your devious side and think like an attacker. Good luck!